Students will be able to identify the extreme values of functions. In exercise 1 through 4, find the extreme values and where they occur. Well, we have an absolute max up here, and we have an absolute minimum at both of those endpoints. So an absolute maximum of 2. 2 is the actual maximum value, and that's happening at x equals 0. We have an absolute minimum of 0, and that's happening at x equals plus or minus 2. Here we have an endpoint up here. There's an absolute maximum, and we have an open dot down here, so there's no minimum at all. This function will decrease forever and never get to 0. So we have an absolute max, or a global max, of 5 at x equals 0. In exercises 5 through 10, identify each x value at which any absolute extreme value occurs. Explain how your answer is consistent with the extreme value theorem. We don't do that. Well, there's no maximum value because that function will increase forever. There's no local maximum value here because that function will increase forever. And this function is decreasing forever at b. So we have no minimums and no maximums on this graph at all. And this point right here is not a maximum because there are points lower and higher than it. Here we have, let's see, that's going to be a minimum. We have a local minimum. Local minimum at x equals a. And this is our overall minimum. So this is an absolute minimum at x equals b. Exercises 11 through 18 use analytical methods to find the extreme values of the function on the interval and where they occur. Identify any critical points that are not stationary points. I don't even know what that is. We don't cover that. So we have endpoints here. So we'll need g of -1 and we'll need g of 1. And then we'll try to find any points in between that could be a critical point, which is a minimum or a maximum. G prime of x is equal to -e to the negative x, which is -1 over e to the x. Now we're concerned where first derivative is either 0 or undefined, and this function cannot be 0 and it cannot be undefined. So there's no internal points that we need to check. Now if we plug -1 into this, we get e to the -1. That's e. When we plug 1 in, that's 1 over e. It's really e to the -1. Now that's going to be your maximum value. So we have an absolute max of e at x equals -1 and an absolute minimum of 1 over e at x equals 1. And here's the graph, and you can see here's the maximum value on this side, and here's the minimum value over here on this side, and it doesn't twist or turn. It doesn't do this. So there's no internal minimums or maximums. It's not doing that. Number 18, we have f of -2, f of 3, and f of -2 would be -2 to the 3/5, and 3 would be 3 to the 3/5. Now f prime of x is equal to 3/5 x to the -2/5, which is 3 over 5 times the 5th root of x squared. 0 makes this undefined, so we want to know about 0. If we plug 0 in, we get 0. However, we have 0 here, and we have 3 here, and -2 here. Now, if we plug in -1, that's a positive. That's 3 over 5 times, well, it's 3/5. So that's positive to the left of 0. Then if we plug 1 in, we get a positive value again. So this function is increasing. It goes to 0 and then keeps increasing. So that's not a minimum or a maximum. So we can say absolute max of whatever, let's see, 3 to the 3/5, and that's happening at x equals 3. And we have an absolute minimum of negative 2 to the 3/5. And that's happening at x equals negative 2. In exercise 19 through 30, find the extreme values of the function where they occur. We don't have ending points on this. Every point is a possibility now. So dy dx is equal to 3x squared minus 6x plus 3. Now we're interested where this function is 0, where the derivative is 0. So 3x squared minus 6x plus 3. Let's take out a 3. We have x squared minus 2x plus 1. And that's 3 times x minus 1, x minus 1. So the critical value is at x equals 1. Now let's see if the derivative changes signs over 1. So we can have 0 and 2. Now if we plug 0 into the derivative, we get a negative times a negative. That's a positive. And if we plug 2 in, that's a positive times a positive. That's a positive. So we do not have any minimums or maximums on the entire graph. If we look at that graph, it increases to 1, and then it keeps increasing after that. So this is neither a minimum nor maximum. Let's talk about the domain of this function. First of all, you can take the third root of anything, so we're not really worried about negative values, but if we factor this 1 minus x, 1 plus x, we find out that x cannot be plus or minus 1. Now that's what makes this function undefined. Let's get the derivative. Y prime. Well, first of all, let's not do let's change to make the derivative a little easier. We're going to change this to 1 minus x squared to the negative 1/3. Now y prime is negative 1/3 times 1 minus x squared to the negative 4/3, and then times negative 2x, the derivative of the inside. Now negative times a negative is a positive, so we get 2x over the third root of 1 minus x squared to the 4th power. 0 makes the derivative 0, and we cannot allow x to be plus or minus 1 because then the bottom is 0, and that makes the derivative undefined, but we are interested in those values, negative 1, 0, and 1. So we cannot equal this one. This one's fine and cannot equal that one. How about we plug in negative 2? We have a negative over, and then if you take negative 2 to the 4th, that's a positive. So negative over positive, that's negative. So this function is decreasing to negative 1. But there's a vertical asymptote there. That's what's causing the first function to be 0. So vertical asymptote 0 in the denominator anyway. So how about negative 1/2? Negative 1/2, that makes the top negative over, and the bottom is going to definitely be positive because of that 4th power. So we have negative. I was going to write positive. It's not positive. It's negative. All right. That means the function is continuing to decrease. That means we don't have a minimum or maximum there, but we already knew that we have a vertical asymptote there. How about a positive 1/2? That makes the top positive 1, and the bottom's going to be positive. That's positive. We just made 0. The function is going from decreasing to increasing. We just made that a local minimum. And then 2. Positive over positive, that's positive. So all we have is a local minimum of, if we plug 0 in, we get 1 over 1 of 1 at x equals 0. If we take a look at the graph, here the function is decreasing. Again, decreasing when we jump over that vertical asymptote. And here is our local minimum. Now, it's not the overall minimum because we have values lower than this one. And then here's that other vertical asymptote. The function increases, and then when it jumps over the vertical asymptote, it continues to increase. In exercises 19 through 30, find the extreme values of the function and where they occur. So we have y prime is equal to bottom, x squared plus 2x plus 2 times the derivative of the top minus the top times the derivative of the bottom, 2x plus 2. All over the bottom squared. X squared plus 2x plus 2 squared. It's equal to x squared plus 2x plus 2 minus 2x squared. Let's see, there's the 2x squared. 2x and 2x is 4x and plus 2. So x squared minus x squared, I know there's a denominator yet, negative x squared. So I got those two taken care of. 2x minus 4x is negative 2x. And then 2 minus 2 is 0. And that's all over x squared plus 2x plus 2 squared. And we can take a negative x out, and that's x minus 2 over x squared plus 2x plus 2 squared. So we're interested in x equals 0 and x equals 2. Now we cannot make the denominator 0. That doesn't factor. So let's put this on a number line. We have 0 and 2. So let's check negative 1. If we plug negative 1 in the derivative, we get negative, negative, negative over a positive. So that's negative. So this function is decreasing to 0. Remember, 0 and 2 is those are the two we're looking at. If we test 1, we get negative, positive 1, and 1 minus 2 is negative over positive. So now we know 0 is a local minimum. Then 3. Let's plug 3 in. Negative, positive, because we get the negative, positive 3, and positive over positive. That's negative or positive. That's going to be negative. So we have a local minimum of, let's see, 0, that's 1/2 of local minimum of 1/2 at x equals 0, and a local maximum of, when we plug 2 in, we get 3 over 4 plus 4 is 8 plus 2 is 10. I'm getting 3/10 of 3/10 at x equals